Monday and see how much of this you're getting. Now, today's topic is quite different than what we've been working on. So, I put it over here, a little summary of what's going to be on this quiz today. We got chapter 1.1, which was on the function family. And transformations. And then we got chapter 1.2, which was, you probably didn't notice, it was entirely absolute value. And it was on transforming absolute value functions. Not necessarily given a parent, but given anything random. And then today, chapter 1.3, and it's quite different than the other two. Check out what is it called? Oh, that was modeling with linear functions is today. So this will feel like something you've done before. Focusing just on straight accident. And that's it. That's all the topics on your quiz Monday. Did everybody write the assignment down? Random 1, 4, 6, and 7. It'll be typed here. And then you can see it over there. And I try to also say it out loud, but I don't always, so look for it. Alright, MTR. The poster over there on the assignment wall in between the two white posters, those are called mathematical thinking and reasoning standards. And we're supposed to be checking in that we're doing those things on a regular basis. So number 7 is applying math to real life scenarios. And we have to do that. I mean, that's like people's number one complaint about math class is like, is it even real? So I think every problem we do today is something about real life. So formula number 2. M equals y2 minus y1 over x2 minus x1. Good old slope formula. What's that? Oh, so that's slope-intercept form, which we will be using today also. And we're also going to be using point-slope form today, if you want to write them all down. And point slope form always looks kind of crazy when you first see it, but it really is just this formula rearranged. Like if you were to put parentheses around this and multiply both sides by x2 minus x1, you get point slope form. Like this and this are the exact same thing, written differently. And this is exactly this, but you're at the y-intercepts, not any random point. So. Any more questions? Yes. No. Yeah. No. That just stays x. And this one just stays y. So I guess that is a difference between that one and that one. Typically with this one, you know 2 points. And with this one, you know the slope and a point. Very good. Any other questions? All right, let's open those books up to yesterday's work, page 30 first. Let's go to page 30. Pretty annoying. I'll be alright. Maybe this is it. Nope. So you're checking your answers. Hopefully you already checked the odds. For 16, you want to do a vertical shrink of 1/2. So that means you need to distribute 1/2 into the entire function given. And you should have gotten g of x equals x plus 3. Number 17, for the words that are horizontal, I've highlighted in blue, you need to do reciprocals. So the a value is 1/2. What I actually put into my function is the reciprocal of that, which is 2 over 1. And you don't distribute it to the whole thing, you only put it in front of x. So if it says horizontal stretch or shrink, use reciprocal. That's the only time you ever need a reciprocal. Reciprocal. This is the only time you use a reciprocal, the horizontal stretch or shrink. So I better do number 19. That reciprocal would be 1 over 2. So g of x is 1/2 x minus 3. And number 20 was vertical. Now 20 I think is the most difficult one to get right. So the weird thing about 20 is it's vertical, but there's absolute value bars. So it's quite different from number 16. In 16, when I had to do a vertical, I was able to distribute in because it's a regular linear function. I use parentheses, I can distribute in. You are not allowed to distribute into absolute value bars. It breaks the PEM rule. parentheses, grouping symbols. Absolute value bars kind of falls into that. You can't, what happens in here has to happen before anything gets multiplied from the outside. So when I distribute, I end up having that 3 right in front of the bars. There's like an invisible 1 there. So the 3 lands there, and then it goes past the absolute value bars to the k value. So what was in the bar stays there, and the stretch is present in the a value and the k value. Okay? And that would be the same in a quadratic. You couldn't distribute into a quadratic either. I'm going to make this a visible note here. Do not distribute into absolute value bars. It'll land in front and it'll go to the end, not inside. Anybody else remember something kind of weird or tricky about these problems here? These 6 problems we should talk about before we go to the other page? All right, no questions. Let's go to the other page, which is page 15, which shifts from transforming equations to all of the functions. It goes back to chapter 1.1. Alright, on 25 we have a linear equation going right through the center. I need to shift it up 2, and I need to change the slope. The slope will be stretchier. The slope will be up 3 over 1. So I'm going to start with my dot at 2, and I'm going to stretch up 1, 2, 3 over 1. I'll go the other way, 1, 2, 3 over 1. And what I see here is a vertical stretch. It's steeper, and it's shifted up 2. This one was kind of tricky. So you got your parent function. It's shifted up 5, and then the negative sign means there is a reflection. So instead of going up 1 over 1, you got that negative slope. All these skills building together. Okay. 27. You got your parent parent absolute value V shape. Wow. I put it going down. Here's the parent. Alright, this one's going to be down 1. So I'm going to put it starting down 1. And now this is like the slope of the branch. It's going to be down 3 over 1. It's a vertical stretch and a reflection. There it is. Down 3 over 1. Skinnier, it's opening down, and it starts 1 unit lower. if you've done all these assignments, you have these parent functions memorized now. This one's going to be up 1. So I put my dot here. And this is the slope, up 3/4. That doesn't look symmetrical. So it's up 1, and it's a bit wider, so they are kind of overlapping here at the ends. This is a little note. This is called a vertical shrink of 3/4. You change the slope to up 3/4. Looking at 29. The down 6, easy peasy, no problem, right? But how do we do this 1/2? That one's kind of tricky. We haven't had a chance to talk about anything like that before. So I got the parent quadratic. It's 0, 0, 1, 1. The next point would be 2, 4. It's a curvy U shape, right? I got to take that down 6, but how do I account for this vertical shrink of 1/2? So instead of going over 1, up 1 like the parent will, down here we're going to go over 1, up 1/2. Instead of over 1, up 1, over 1, up 1/2. And that's a vertical shrink. Instead of going up 1 whole unit, it goes up half that, and you land halfway in between. And instead of over 2, up 4, it goes over 2, up 2. So every y value is half of what the parent function would be. So this one should look wider, and on your own graph paper, this is going to work out easier than on here. But I'll continue to do it on here because I know a lot of you guys are working on there. 30, last one. Get the parent function in there. So the quadratic, it starts at 0, 0, over 1, up 1, over 2, up 4, and it's symmetrical. So there's the one I want you guys to have memorized. Your life's going to be easier if you memorize this one. That's 0, 0, 1, 1, 2, 4. This next one, I'm going to have to shift it down 3. That K value means I have to go down 3 units. So here it is, 1, 2, 3. And now I have to address the 4 in front, which is a stretch. Any idea how we can, what effect that 4 will have on the first point? I'll let you guys think about it for a while. I'm going to take a guess from the room before I tell you. What are we going to do about this vertical stretch of 4? Typically, from here, we would go over 1, up 1. Since there's a 4 in front, what should we do? Go for it. Over 1, up 4. Okay? Stretching it by 4. Just like this was over 1, up 1/2. When there's a 4 in front, we'll go over 1, up 4. It's going to be significantly skinnier. It's skinnier by a factor of 4. 1, 2, 3, 4. 2, 3, 4. And the next point would be over 2, up 16. It's a very skinny parabola when there's a high number in the A value. We've been working with numbers like 2s and 3s and changing slopes. This has been our first opportunity to talk about strengths. So in 28, with the branches, change the slope. And now in 29, it really affects where you put your first point. This is how far up you go when you go over 1. We've got a question on stretches and strengths. Kind of the last piece of understanding these transformations. Things are coming together for you guys. If there's no questions, let me walk around real quick. And then we'll move on. Oh yeah. You know, it would be kind of advanced if you get this and to think about what's the domain and range of these graphs. If you're looking to extend your understanding, consider domain and range. Yeah. All right, you guys, pretty good. You hung in there. Got your graphs done. Everybody flip to chapter 1.3. The very beginning of chapter 1.3. Oh, just a moment. Hey, it's page 37. You guys are going to do A through C on this Explorer, and you need to talk to the people next to you about it. It says on the Explorer, it's really supposed to be working with a partner. So read it and try to figure out some of the vocabulary. Try to figure out what's going on in the table. Okay. Work with a partner. A company purchased a demolition robot for $87,000. Any idea what a demolition robot is? Yes. Destroy things. It's $87,000. How much does a brand new truck cost? Does a brand new truck cost $100? Like a Ford? Yeah, pickup truck. 60, 50, $60,000 for a really, really good, maybe 65 now for a really nice new truck. And so this demolition robot costs more than a brand new truck. I mean, we're talking a really, really serious robot here. I don't know if it's demolishing buildings, if it's demolishing cars. Maybe we're thinking of a junkyard. Maybe it's demolishing factory equipment that needs to be upgraded. But I'm interested. I'd like to see a YouTube video of this thing. It depreciates over an 8-year period. What do y'all think the word depreciate means? That is an accounting vocabulary word. Loses value over an 8-year period. Why would it lose value? It's being used. As soon as you buy a brand new car and you drive it off the lot, it's not worth as much. It's getting used, so it's depreciating. What type of function do y'all think this is? Which function family? Is it constant, linear, absolute value, or quadratic? What makes you think it's linear? Okay, x values are typically consistent anyway, but not always. How could we decide if this was linear or not? What can we do? If only there was a picture. Or an equation. You guys go ahead and graph it, and then we can figure it out. Sketch a graph. This one, because I know there's no negatives here, we're going to go ahead and put, let's see here, let's put years down here, and let's put value here. And we're going 0 through 8, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And our volume, shoot, we got to get up to 90,000, so maybe we'll go by 10,000. So we'll go 10, 20, 30, 40, 50, 60, 70, 80, 90. And we got to draw some dots. So we're at 87, just below 90. Okay. We got 1 just around 80,000. We got 2 at 72. We got 3 at 65. We got 4 at 58. We got 5 at 50. We got 6 at 43. We got 7 at 36. We got 8. What? Did I mess up? We got 8 at 43. We got 9 at 36. I feel like I messed up. And we got 10 at about 30. 5, 6, 7, 8, 9, 10. Yep, I got lost in those last two. 6 was 58. Oh, the spreadsheet's throwing me off. 6 was 43. 7 is 36. And 8 is 29. There we go. So how's it look, guys? Does it look curvy like a quadratic? Does it look absolute value, or does it look linear? it looks linear. And it actually says it right here, like a linear function. So visually, this guy is linear. All right, so the directions say explain how you can write a linear function to represent it. Let's go ahead and write a linear function. We're looking for an equation in y equals mx plus b. I'll give you a minute. What's this up a linear function? What do you need? What's the m in the linear function model? I'll give you a clue. We wrote it in Bellwort. What did we write down in Bellwort? See a couple people with calculators. Calculator would be helpful. Wasn't everybody grab a calculator out of your bag? Let's see who got their supplies. This is gonna be better with the calculator. Okay, you can have a seat. I get it. Who found the slope? Besides y'all two over here. Anybody? Did you find slope? What'd you get?
72,050.
Okay.
10,250.
Like that?
No, without the 0
Good. Is this what you got, Anthony? All right. How'd you guys figure that out? Which 2 points did you use for your slope formula? Which points did you use? Use this for x1, y1, and this for x2, y2. So 0, 8, 7, 0, 0, x1, y1, and 1, 7, 9, 7, 5, 0, x2, y2. Put that into slope formula. And you end up with negative 7250. And that's your slope of this line. I'm going to go ahead and connect it. Boom, boom. All right. So the next part, how you can write a linear function. Sketch and draw for this function. Explain why this is called straight line depreciation. Some things don't depreciate in a straight line. This is depreciating in a straight line. Interpret the slope as a part of your assignment today. So I want you to write this down. This means use a complete sentence to explain slope. So what do we think this negative 7,250 means for this robot and the business owner that's using it? Let's get a sentence down about m equals negative 27250. Vincent, you do it. What's this number mean for this robot? The slope.
Going down.
Every year. Well said. Okay, so I'm going to just add in the value of the robot. So, large companies, corporations, they have to know exactly how much their company is worth if they want to sell stock options. You have to know the net worth of your company if you want people to invest in your company, and you have to know the net worth of your company because you have to pay taxes on that to the government. So sometimes you want your company to look like it has a really high net worth, and sometimes it's valuable to look like it has a low net worth. So when the government wants you to pay taxes on all of the things that your company has, if you've been using this robot for 7 years, it's not worth what it originally was. This robot's called an asset in your business. So the government wants to know like how like if you're sitting in a parking lot full of Ferraris, the government wants to know how much is your business worth. It's not what's in your bank account. It's what do you have in your business. It's all the things, and that includes equipment, robots, machinery. Um, so people don't necessarily want to say that they have 20 demolition robots at this value if they have to pay taxes on the worth of their company. They depreciate it each year because it isn't worth as much. And they can't just say what they want. They have to prove it with numbers and accounting. So there's all of these like official rates that companies are allowed to use to depreciate their equipment. And that's what accounting is. So business owners really rely on their accountants to keep track of these things. It's important for taxes and for stock options. Okay. Let's finish our linear equation. I'm going to go with y equals negative 7250x plus, and right here we need to do the y-intercept. This is your y-intercept, which is the b value. So I'm going to put 8700. So our robot started at 87,000 and it's decreasing 7,250 each year. And this is important for all equipment in every business here in the United States. Depreciation. Accounting's so interesting when you get into all the details. Especially for things like hospitals. They have so much equipment that they have to keep track of. All right, you guys, I'm going to just take a look at your assignment with you for a minute. So everybody go to page 45 so I can help you understand what you're looking at. It's number 1, 4, 6, and 7. So that means that you can check 1 and 7 in the back of your book. You have those answers. Okay? It says use the graph to write an equation of the line and interpret the slope. Interpret the slope means complete sentence. And write an equation is y equals mx plus b. So if you need to use slope formula to figure out the slope, use slope formula. If you can just count rise over run, just count rise over run. So I'd say 1, 4, and 6 are pretty straightforward using slope formula and finding the intercept. When you're completing the sentence, use the title of the graph. This is about how much your meal costs according to tip. This one's about how much a tree grows over time. This one's about how much you drain in a swimming pool. And then what's this one about? I'm not going to tell you more about this. I want you to really engage in that and think about it. Well, it's just like what we just did. So, like number 1, let's go ahead and figure out the slope. We could, because it's a little easier than what we did just now because we had to graph that one ourselves. Okay, this one's already graphed. So maybe you guys just want to use the rise over run method to find the m value. It looks like I'm rising 2, and I'm running 2, 4, 6, 8, 10, running 10. So this one, the slope is 1/5. So for my equation, I'm at y equals 1/5 x plus, what's the y-intercept? Wherever the line goes through the y-axis is the y-intercept. So here it's 0. So there's your equation, and you don't need to write 0. So the equation for tipping is y equals 1/5 x, which is 20%. You tip 20%. 1/5 is 20%. Now we need to interpret that. This can be a lot of different things. One way to interpret it is you could say the tip increases $2 for each $10 meal. Okay, so I have a sentence describing slope, and I have an equation, linear equation for that. All four should have an equation.